Hi, I'm Anshita. I'm from TeamEdgecombe and I'll be presenting the tool JavaMOP Efficient Parametric Runtime Monitoring Framework. The authors of the tool are Dr. Jim, Dr. Meredith, Dr. Lee, and Dr. Rosu, and they presented the tool in ICSC 2012 conference. So the motivation behind the tool is efficient parametric monitoring of the properties. Now, what are parametric properties? These are the properties that describe behaviors of objects which a program should conform with during its execution. They describe use of protocols for classes, preconditions for using classes, prohibited activities, and so forth. Now, parametric monitoring is useful in all phases of SDLC, and it helps in detection of errors, recovery from errors gracefully, and increasing system reliability or security. Now, overview of the tool. It is based on Java programming language. The prerequisites for installation and usage of the tool are AspectJ compiler, Java runtime environment, and RV monitor. RV monitor is runtime verification monitor, which is responsible for generating monitoring code, whereas AspectJ compiler is responsible for generating .aj files which call this monitoring code. The interfaces supported by the tool are command line and web. So this is the architecture of the tool. As we can see here, this is the logic repository in which there are various logic plugins pertaining to the logic formalisms such as context-free grammar, finite state machine. The JavaMOP component has several translators to interpret pseudocode from these logic plugins in the repository into AspectJ monitoring code. Now I'll start with the demo of the tool. JavaMOP has several predefined properties such as hasNext, safeenum, safelock, which are based on Java API properties. Users can define their own properties with the help of .mop files which they have to create based on JavaMOP syntax, which can be referred to from their project website. Now the hasNext property is the property that I'll be demoing. It ensures that one does not use the next element in an iterator without checking for the existence of a next element. So basically property states that every time a next event is seen, there should be a hasNext true event immediately preceding it. I will first now show you the MOP specification file for this property. As we can see, there are three events: hasNext true, hasNext false, and next event. And on violation of the property, this is the error message that gets called: next call before hasNext. Now let's compile this property by using this command. Now a bunch of things happen. Firstly, a .rvm file is generated with the help of RV monitor. Then a .aj file is generated with the help of AspectJ compiler. I will show you these two files that are generated. So this is the RV file, which is the monitoring code that will monitor your target program. And this is the .aj file, which has point cut points. And these are the events: next event, hasNext true event, and hasNext false event, which are responsible for calling the monitoring code. Now this is the target program that we are working with. It is a simple program having a vector. Elements are added to the vector. This is the iterator, and the next method here is getting called before the hasNext method. So here we see there is a violation of the hasNext property, and hence there should be an error that should be printed on the console. Now let us instrument the code that was generated in .aj file. Now this command, what it will do is it will weave the code in .aj file with the target program. So whenever there is a call to the next method, the next event gets inserted right above that line. So before the next method gets called, that event which will get called when we run this weaved program. So in this way, the system knows that there is a violation, and then the corresponding handler code should get executed. And in that case, this next call before hasNext should get printed on the command line console. Now let's weave the code. Now the weaving is complete. Let us run the target program. So we can see there's an error, next call before has next. Now if I tweak the program a little and comment out the portions that are violating this property, the error should go away. Now let's follow the same procedure again and run the program, compiling the MOP file, weaving the code with the .aj file, running the Java program. The error goes away. Now jumping back into the presentation, the advantages of using this tool are it allows multiple differing logical formalisms. By that we mean the context-free grammar and the finite state machines logical formalisms. They are supported by Java MOP. Along with that, a lot more formalisms are supported. Most efficient in terms of runtime overhead, and it is very competitive with respect to memory usage as compared with the other parametric runtime monitoring tools on the market. The limitations are it is heavily dependent on the AspectJ compiler, so it only allows events which can be defined in the standard AspectJ. It cannot do any weaving time optimization because it relies on external AspectJ compiler for weaving monitoring code. For more information, refer to the project website. Thank you.